Hello and welcome again to EMCLIVE 2018. It is just after 1 o'clock on the East Coast of the United States. I'm Graham Kilshaw with Interference Technology, and we're the presenters of EMCLIVE. Thanks to everyone who's registered and participated so far in this year's 3-day online event. We have over 2,000 registrations this year. It's a great show. And we have some great presentations lined up for you for the remainder of today and throughout the end of tomorrow, Thursday, too. The next presentation is a product demonstration brought to you by Siglent Technologies. The title of this presentation is Expand Pre-Compliance and RF Test Capabilities with the new multifunction Siglent SVA1015 analyzer. The presentation runs about 10 minutes, followed by a short question and answer session. If you have questions, please post them at any time during the presentation. Simply enter them into the Q&A panel on the left side of your screen, and we'll answer as many as we have time for at the end of the presentation. If you'd like a copy of today's presentation, PDF slides are available on the right side of your audience console. And our presenter today is Jason Chonko. Jason's primary role at Siglent is to help customers get the gear they need to excel. He has over 17 years of experience in test and measurement, and he's seen a little bit of everything from nanoamps to gigahertz. And so, without further ado, I'm pleased to turn the presentation over to Jason Chonko. Over to you, Jason.
Thank you very much, Graham. I appreciate that. Thank you, everyone, for attending today's presentation of the SVA1015X. Get this. All right. Oops, I went one ahead.
Now let's take a look at the SVA1015X and some of its features.
I already messed it up. Okay, here we go. Okay, so spectrum analyzers and pre-compliance. So many of you here are looking for solutions to your pre-compliance needs. Just wanted to put a brief intro here about pre-compliance. So many of you, if you are not aware, pre-compliance is measuring the electromagnetic output of a particular board or product or assembly before going to the compliance lab for certified testing. Solving EMC issues before you go to the compliance lab is going to save you the number of times that you have to go back to the compliance lab. Again, the idea here, we want you to get done with all of your compliance testing or pre-compliance testing and feel very confident that when you go to the compliance lab, you're going to be ready to pass that first time or the second time through. This is going to save you money and also decrease that time to market by minimizing the number of trips that you're going to have to go back to the compliance lab. And some tools that are going to help you get there. Pre-compliance has a lot of different ways that you can address that particular test style. A spectrum analyzer is going to be a basic tool that's going to provide the eyes to the engineers to help them see what's happening in order to record changes in your particular process. If you were to make a change, you'll be able to then establish what those changes are by comparing information that you've collected using that test equipment. And also in this particular case, a VNA or vector network analyzer can be a helpful addition to the lab by providing the ability to test cables and components that can be used during the test as well as solving some of those electromagnetic compliance problems. And so with this new product, Siglent has introduced a spectrum analyzer. This is the Siglent SVA1X series. Is based on our Siglent SSA3000 series of spectrum analyzers, but it also includes a vector network analyzer option. And so this particular design, it's compact. It weighs a little less than 11 pounds. It's a little bigger than a shoebox. So we have some video coming up later that will show the actual size of the instrument. But just for now, a little bit bigger than a shoebox. It's based on a swept super heterodyne design. Many classic spectrum analysis products have been built around the super heterodyne. It's very stable, very flexible as well. This particular instrument, the SVA, is going to run from 9 kilohertz to 1.5 gigahertz span. That's going to give you a perfect radiated and conducted emission span. The VNA section is going to run from 10 megahertz up to 1.5 gigahertz. The minimum resolution bandwidth for the SVA is 1 hertz, and that's going to give you a very fine resolution if you need to see two signals that are going to be very close together. Again, the closer they are, the lower the RBW will help. The lower RBW will help to resolve those two signals as they get closer and closer together. So you can identify the source of that particular radiation or that particular electromagnetic event using the resolution bandwidth settings. And that also lowers the effective noise floor or measurement floor of the instrument. The display also has two limit lines that include pass-fail operation and peak table capability. The limit lines are going to allow you to very quickly view where the conducted or radiated emission lines, the maximum values for that particular test or the particular device that you're testing, can be set directly on the front panel of the instrument and very easily referenced during any kind of checks that you happen to be making. This product also includes an optional EMI kit. That includes an EMI filter, which is 6 dB, or is defined at 6 dB instead of the 3 dB Gaussian filter. It also includes the FCC resolution bandwidth settings of 9 and 120 and 250 kilohertz for RBW, and also includes a log frequency plot. So many many spectrum analyzers used in electromagnetic testing feature a log-log plot. So we also have that capability. And a DANL, which is the displayed average noise level, is less than 150 dB. Also includes a tracking generator or has a tracking generator option. And so now what I would like to do is show a brief introductory video as well as a video follow-on that shows some of the standard functions and optional features of the SVA. Get that started just momentarily.
Now let's take a look at the SVA1015X and some of its features. As you can see, it is very similar to the SSA3000X, that's the Siglent spectrum analyzer series, except it does have some pretty significant differences from the user interface as well as some of its test capabilities, as shown previously. It has a 10-inch diagonal display, very similar to the SSA3000, but the major difference here with this display is that we have the ability to move things around with our finger. It's got a nice touch screen, so we can move the amplitude, we can move things around. Now let's take a look at the SVA1015X and some of its features. As you can see, it is very similar to the SSA3000X, that's the Siglent spectrum analyzer series, except it does have some pretty significant differences from the user interface as well as some of its test capabilities, as shown previously. It has a 10-inch diagonal display, very similar to the SSA3000, but the major difference here with this display is that we have the ability to move things around with our finger. It's got a nice touch screen, so we can move the amplitude, we can move things around. We also have a quick touch assistant that has a number of common features, including screenshot as well as peek. We can quickly shrink that and move it off to the side, out of the way. Now let's take a look at some of the other things that we have here. We can go to the mode, and we have spectrum analyzer, that's standard, modulation analysis, distance default, and VNA. Those are all going to be additional options. We can go quickly over to the frequency bin or frequency button. We can put in 150 kilohertz to 30 meg. Here we're just going to do a quick conducted emissions test. So we've set our frequency very quickly. Also, a nice feature, we can add mouse control. So we can plug in a USB mouse. Here we're going to use a wireless mouse, and that makes some of the menu-driven features a lot easier to get to. We can run over to System, and we can start to configure this for a conducted emissions test. So the first thing we're going to do is configure our bandwidth, or first we'll do the log scale. That's going to set it up a little bit more like an EMI receiver. Then we're going to change over to the EMI filter. Again, that's available with the EMI toolkit. That's going to give us the resolution bandwidth settings of 9 kilohertz and 120 kilohertz, the FCC bandwidths. So we'll drop down to 9K. And we will enter that, and now we've got log 150K to 500, or I'm sorry, 150K to 5 meg or 30 meg, and now we're going to set up some limit lines for conducted emissions, and that's very simple. We've got a line mode as well as a point mode. Go into point mode. We're just simply going to add, create an X point and a Y point for the amplitude. And we will enter those values here with the on-screen keypad, creating our limit line just point by point. We also do have a software kit that allows you to create limit lines automatically using that software. That's called Easy Spectrum. That is available for free, and it works with the 3000 and 1000X series. So here we've created 2 limit lines. I did a little fast forward there. Sorry about that. Little 2 limit lines, and then we can also save those limit lines very quickly just by going into the system menu and saving that as a limit. We can also save setups. Here we can quickly enter a name for that limit file, and we can use that on-screen keyboard and quickly hit enter, and we can then save that limit file for reuse later on. Now let's take a look at some other features on the SVA. Here we're going to go into the mode area and mode menu and take a look at modulation analysis. The instrument does have optional ASK and FSK demodulation capability. Also, we've got a number of nice features with the VNA side of things. Let's take a closer look at those input ports, or the input and output ports. You'll see we've got port 1 on the source and port 2 on the input. That's going to indicate that this is not your standard spectrum analyzer. This is going to give us that ability to make some other measurements. Here we've enabled the distance default function. That gives us return loss, VSWR, and reflection coefficient capability. And here we're going to quickly perform a calibration step. I'm going to go over that quickly for time. Connect up a cable, and now by rescaling, we can take a closer look at some of the some of the problems that we may have with a cable. So we can quickly do a calibration, which is open, short, and 50 ohm or load, and then we can connect our cable up, and now we can see where we may have a fault in that cable. We're basically measuring where there's an impedance change, and measuring that distance to the or the time of flight to that particular impedance change. Here we've got 3.27 feet, so we could take a look at this cable and go out 3.27 feet from the end, take a closer look to see if we have any nicks or any visible problems with it, and make that repair. We have a number of settings, velocity factor, and a number of other things that we can help to tailor to the particular cable that we're testing. Now let's take a look at some of the other modes of operation. We've got vector network analysis. This is going to provide S11 and S21 measurement capabilities on RF components. So we have a number of graphing capabilities here. We've got, again, log, linear, phase, group delay. Most common is going to be the Smith chart. We're going to run up to Smith linear and magnitude, and now we're going to replace that cable with a 50 ohm termination. We're going to compare to 50 ohm terminators. Here's a high quality 50 ohm terminator, and the complex impedance, which is displayed by the Smith chart. You'll see it's a very tight dot in the center, and that's actually going to that's what we want. We want over frequency. The SVA operates from 10 meg to 1.5 gig. The tighter that loop is, the closer to 50 ohms it is. Now we'll put a lower quality 50 ohm connector, and now or terminator. Now you can see it's no longer a dot. That means that over the operating frequency range, this is not exactly 50 ohms. And so we can start to characterize RF components using the SVA. We could qualify whether our RF components are going to be working properly. Chokes, filters, cables, connectors, adapters, all sorts of things can be tested with the SVA in this way. So it's a very, very useful instrument, not only for pre-compliance, but also for RF characterization of your components as you move forward. Let's flip it around just to take a look at the available connections. So it's got a USB connection and a LAN connection for remote programming, RF input, a reference 10 meg out and reference 10 meg in, as well as a trigger. Again, so fully automated control can be possible with the SVA, as well as the front panel. Mouse control also supports keyboard and USB hubs. The SVA1015X is truly a multifunctional instrument.
All right. So we have covered the basics of the SVA. Now I'd like to summarize. So this product is just about to be released. It's going to be available soon. We've got about 4 to 8 weeks for the full release. Keep your eyes peeled on the SiglentAmerica.com website or with the Siglent newsletter. We'll be releasing that information very soon. Pricing is going to be less than $2,000 for the base spectrum analyzer unit. So this is going to stay within the same realm of most Siglent products. We're trying to provide as much capability for the least amount of money as possible. This includes the spectrum analyzer functionality. That includes LAN and USB connectivity, as well as free software. In fact, the latest upgrade that I just got for the pilot unit that I'm playing with here also has an onboard web page browser, so we may also have the ability to do some quick controls via LAN that way. It does have convenient one-button screen copy to quickly save screenshots, so everything on the display gets pushed quickly over to a USB memory stick on the front panel for ease of copying that data and that information over for your reports. This particular instrument is also our first with a touchscreen and includes USB keyboard and mouse support. That makes the user interface much easier to use, especially for those deeper menu-driven instruments like the spectrum analyzer. The touchscreen works very well. It has some quick features that you had seen in that demo. Some of the options that are available are that distance default. That's going to be ideal for testing cables. That's actually a frequency domain return loss measurement. That gives you very fine resolution and control over and characterization actually of your cables that you can then compare to later. Gives you return loss, SWR, and reflection coefficient display modes. The EMI toolkit, as mentioned previously, has the 6 dB EMI filter, quasi-peak detector, and the FCC resolution bandwidths that are commonly used for pre-compliance testing. And then the additional option here is going to be that VNA. That's going to allow you to measure S11 and S21 parameters, give you complex impedance, and multiple charting options including Smith, polar, linear, and log magnitude. Continuation of that summary, we've got the modulation analysis, maybe not so important for EMI and pre-compliance, but also another part of that toolkit gives you ASK and FSK knee modulation capability. And then the advanced measurement kit option, which gives you common broadcast measurements, including TOI, ACP, as well as a convenient spectrum waterfall and monitor chart on the front panel. We also do have near-field probes available and manual calibration kit, including short and 50 ohm open, as well as a carrying case. So keep your eyes peeled for news on the SVA release. If you have any additional questions, here are the contact points for different regions throughout the world for Siglent. So we've got a North American headquarters here in Cleveland, Ohio. We've got our Asian headquarters, and then we've got our European headquarters in Hamburg.